Introduction to cosine integral function. Okay, so here are some few random facts about this cosine integral function. We will discuss that in this video. Before we go to this, before we go to the definition, let me remind you that in sine integral function, capital SI of x was integral from 0 to x of sine t by t dt. Yes, and small SI of x was negative of integral from x to infinity of sine t by t dt. Yeah, we had these two functions, and basically this one is capital SI and this is small si. And one thing to notice is, for cosine we don't really have a capital Ci function. Yeah, I mean, we can write this function itself as capital Ci. Yeah, there's no problem in that, but we don't have this function integral from 0 to x. We don't have integral from 0 to x of cos t by t dt. Yeah, in the reason is okay, if in the reason is while we are integrating near 0, yeah, while we are finding the area near 0, you can see that near 0 cos t will be 1 and this will go to 0, and it basically goes to infinity near 0, and that's why this integral diverges. Yeah, since this integral diverges, that's why we don't have this definition for cosine. Yeah, and you can clearly notice that. But cosine integral function can be defined other way, where it converges, that is minus of integral from x to infinity of cos t by t dt. Yes. Okay, so now this is Ci function, and while dealing with Ci function, we will also come across another function as well. So that's why we also name the other function. Again, give some names. It is integral from 0 to x of 1 minus cos t by t dt. Now in this case, near 0, we will just have 1 minus 1, which is almost 0 by 0 form, that is indeterminate. But yeah, that will not really diverge. Yeah, that will have some values. Basically, you can see that this is 2 sine square t by 2 by t, though, so it will basically go to 0 near 0. Yeah, and that converges. And so this is named as Cin function. Yeah, and now about derivatives, we know that due to the definition that Ci of x is integral from minus x to infinity cos t by t dt. If we differentiate this, we have minus. Now basically this will be integrated and evaluated infinity and x. Yeah, so at infinity it will just give us some constant values. If we differentiate, that becomes 0 and minus, and the integral and then differential, so basically over here that will just be cos x by x. Yeah, and we see that its derivative is just cos x by x. Okay, that's good. Now let's find the integral, and then we will have completed our task. So integral of Ci of x dx, we can just use integration by parts with Ci as u and 1 as v. So we get Ci of x, and the integral of 1 is x, minus integral of, now derivative of Ci of x we have just found out to be cos x by x, and the integral of 1 is x. Yeah, and now we can see that the x and x cancel out. That's why the integral will be x cosine integral function of x minus integral of cos x is sin x plus c, and this is the required integral of Ci of x function. Yeah, so this was it for this video. Just to recap, cosine integral function is defined as negative of integral from x to infinity of cos t by t dt, and a similar other integral is here, where it basically goes from 0 to x, and the integrand is 1 minus cos t by t dt, and derivative of Ci is just cos x by x, and integral of Ci is x, Ci of x minus sin x plus c. So this was it. Hope you really enjoyed this introduction to cosine integral function, and look forward to seeing you in the upcoming videos too. Thank you.